Right. So my name is Andre, and I'm working in Commodore for almost 4 years now. And I've been through the process of building our AI SRE, and I'm living with everyone living through this AI transformation, which represents a nice, interesting time for an engineer. And though the transformation is not yet over, we can already share some of the conclusions or at least experiences of how do we live through it. And these days we all have uh, quite good AIs on our laptops, and the SRE is probably one of the best topics to try to automate using these modern AI technologies. I will share what I learned while building our AI SRE, and everyone starts today from their local harnesses, laptop situation, and I will assume that we start there and we will try to build up something more production ready, at least in theory. And then I will try to answer your questions um, when they come. So AI SRE on my laptop, what does it mean? What does it mean to be SRE? And this needs some of the structuring, and I'm approaching this as the more theoretical breakdown of what we learned. And AI SRE as an activity that you do, you can imagine several use cases for it. First and foremost is the incident response. When something happens, when the time pressure is there, this is what we want to automate first, and this is incident response. You want to look for the root cause analysis, you want to find the fix, and you want to accompany that fix all the way to recovery. And this is a lot with pressure of time, the famous stories of on-call through the night, and this is the most typical and the first use case that you do. There's also another type of activity that you do. It's redeployment and reconfiguration, when you want to make sure that whatever idea you have of changing your infrastructure or configurations is safe to proceed with. And LLMs, modern models, are really great with their encyclopedic knowledge of all the technology and ability to reason about it. This is where you enjoy and get the value out of AI with SRE. Third pillar, but it's not necessarily like that, but we found that the impact, if we want to do the impact on SRE life, what is good is to start early, looking at your resources optimization and financial outcomes of what you do. Optimize the costs, identify the underused resources, eliminate those, and save real money, because nothing is better than AI that pays for itself because of the hard dollar savings. Let's say these are the three use cases that we roughly have in our minds. Maybe in your situation, there are something more. It's all compatible. What does it mean to have AI SRE on your laptop? You take usually any general purpose agent harness, pi.dev, Cloud Code, Codex, open code, thousands, not thousands, okay, dozens of those harnesses exist. You give it your CLI tools, you give it your credentials, you authenticate in those tools, you give it maybe MCP services, and then you ask it to do the thing, and it will do the thing. It will maybe do it slower. It will maybe require nudging here and there to do the thing. But this is the beauty of modern AI. It is smart enough to get through. Not 100%. You cannot leave it unattended. There's a lot of hand-holding and supervision required, but you can automate your typical tasks into agentic skills. Those existing skills are published, I would say, weekly. When I'm going into LinkedIn, it is full of happy stories of SREs automating their work. Like in the previous slide, what took hours takes now 5 minutes, and the productivity boost is already there. Uh, Maybe at this moment you're starting to share it around like those people did. Like I can show to you um, these. let me do it like this. Like, for example, if you look for open source skill packs, there are some. They look like this. They look like repositories with these skills. Whatever the author of those skills has put into them, you kind of can trust that and believe that they put the best effort and the best knowledge into those skills. If you have nothing else, you can probably start with that running SRE on your laptop. Um, it's good and it's in a way baseline. I would note shortly that the problem with it is that it creates a sort of illusion of ease of how you do it, and then it's easy to assume that you can scale that beyond your laptop. And today we will exactly going through what does it take to go beyond your laptop. Uh, if we start with a diagram, and I will try to evolve this diagram a bit, this is the diagram of your laptop. It has agent harness. So those coding agents of various sorts, they are generally called agent harnesses, which have skills built into them. Then you have some tools like AWS CLI and kubectl on your laptop. You use your personal credentials, and sometimes you go out for external MCP services if you use the services provided by like GitHub or Datadog or something. This is our baseline. What is the problem with the laptop? There are a number of problems with the laptop. Of course, you can get through the problem and you can kick the agent until the end, so as to make sure that it concludes and gets to the right conclusion, but it has its limits because you can run as many agents as you have people and their time and attention. So one of the problems is scalability. What happens when you close your laptop? Does agent stop? Or who nudges the agent, who looks at its results, who give it tasks, who copy pastes those incident messages into the agent? So still, if you think of this laptop driven AI SRE, it's very, very limited because it assumes operator is there. If you want to scale out, you will need to remove the operator. How do you make machines to trigger it without operator copy pasting it? You would like to avoid this very dumb step of copying and pasting. When it fails to analyze, how do you troubleshoot that failure and improve it and make this development evolution cycle to complete? How do you tell is your change to the skills and the setup has improved it or not? And for all of the cases that you having, not just the one case that you reviewed, can you share it with your colleagues? How do you share the not only the agent but also the outcomes, the results of it, and how do you make your colleagues to discover those results and maybe the results to serve broader scope of the audience? And finally, how do you take control on the costs of the thing? Because one of the problems of those generic harnesses of the coding agents is that they are quite bloated. They try to address the general case, and because of that, they spend good amount of tokens for the things that you not necessarily want for AI SRE to consider. These are the questions that I would try to answer through my presentation. Let's try to gradually build up on top of the laptop imaginary components that would take it to more professional state. So this is the laptop harness or the laptop setup that we had, but now we need to change one thing. The green plus signs would emphasize where we change the things. So first thing we need to give it a home. We need to make sure that when I close the laptop, I'm not worried that the job stops, that the work stops, and until I open it again, the problem is not solved. So we need to put it into some new home, into a server that is not on my machine. Okay, I can copy my personal credentials into virtual machine, into some hosting, and still keep it the same harness, same everything, just it's somewhere there in the cloud potentially. The second step is I would like to actually scale it because it does not make sense to have one-to-one ratio between agents and humans. This is not why we invented these AI agents. We invented them to be able to delegate them much more work than we as humans can process. So for that, we need to detach AI from driving human and ideally make them autonomous. And for that, we need to scale. And the scale assumes that there will be some agent orchestrator that would be starting the new agents when there's new work coming for them to do, shutting them down to save the costs of infrastructure when you don't need them. The good thing about agents and LLMs that most of the work is very much input-output related, which means you don't need a lot of CPU. You maybe need some of memory, but you don't need to calculate lots and lots of things. This is what may be surprising to you because you know that coding agents are quite CPU. They're happy to burn your CPU a bit. That's only coding agent problems because they do a lot of things in the background. Most of the focused per use case agents, they would not be doing that much of CPU consumption. They mostly would defer to either tool call or LLM call, and they would basically sleep awaiting for the response. And that the response from LLM is measured in seconds, sometimes tens of seconds. So to do in between. So it means that you don't need too much of CPU, too much of compute to start running dozens and hundreds of agents. And that's the first step. Another step, or the third step, is one of the things that we realized quite early is that the interactive chat is not the best interface to interact with automated agents. It's good when, again, the driver is human and you imply that the human is there, but as soon as you remove the human from the equation, all of the interactive chat and things that come with it, the ability to nudge it, those do not make sense. Instead of that, you want HTTP API. You want something that would be providing you an automated way to trigger the agent and get the response out of that agent. You can immediately think of two fashions of calling agent. One is synchronous when you start and await, but as we know, the agent can take 10 minutes to work. So in most of the situations, you would love to have something like start the session and then query, did it finish or not? And webhooks. When we speak of automating and removing human from equation, it means that you would like to make a webhook interface that would allow your Datadog to trigger the agent and start the work for you. So this leads to actually agent harnesses like Claude Code and other interactive agent harnesses to lose their meaning. In our experience in Commodore, we even started with writing our own harness 2 years ago when there were no Claude Code. So we started our own agent harness to get this agentic loop to respond and do the thing. And in the beginning, it did not require the human. And indeed, it does not require human in 90% or maybe even more than 90% of cases because there's nobody to come and ask the question. You wanted to react to webhook of incident happening. You want to see what it resulted in, what's the conclusion. You don't have any more questions. Here's your root cause. That's it. So this is the important step of giving it HTTP API so you can interact with it not through CLI. The fourth step is you actually don't want it to use your credentials. This is something that is sensitive and security is always the case. So for agents, what we already learned is that we need to make sure that it either uses user identity and propagates the user identity and agent acts on behalf of the user, although it gets through HTTP API. So you would need to solve that through what is the second component on the diagram that is called RBAC. And it's called RBAC because you would also want to decrease the level of permissions as much as possible. So you would enjoy the component that would take user credentials and convert them into access to your AWS infrastructure, but it would decrease the privilege level, downgrade it, so it would be, for example, read-only. You would like to know that your agent is not able to do the harm. And this is one of the biggest gaps from laptop environment, which uses your credentials, and then you're constantly worried for it to do mistakes, hallucinate, being prompt injected. So if you turn it into only curated subset of actions through some identity gateway and RBAC gateway, then all of your operations that it does on your behalf or in a fully automated fashion using agent identity or service account, that is an important step. It's very non-trivial to do, but this is exactly what divides agent that scales out to dozens and hundreds of sessions a day from something that you lack the trust. The trust is the big thing with agents. So this is how you gain trust, but by knowing that there's no credential for it to do harm. It's a very important step. Next is, surprisingly, this is another moment when you evolve the thing into a system that is able to do complex things. You also need to add back the chat interface, but this time you would not be doing that as a CLI interface, because it's very rare occasion when you would like to follow up on something that it has done something. You are not happy with the result. You want to ask why. You want to ask what would improve it to close the loop of the improving your agents. And because of that, you need some way to revive the session to follow up with the question. And it's a great, great tool to actually understand why agent did that, because one of the problems is the lack of visibility into reasoning, and you need this ability to ask and follow up why it did what it did and how would you improve it. For example, one of the most typical things that we were asking in the early stages of Claudia, in these follow-up questions, we were asking which other types of data would help you to find better root cause. And the LLM was saying, yeah, you did not give me Kubernetes events, or you did not give me the logs from the pod. I was unable to discover it. And we were improving the process, making sure that it would get the logs that it was missing to get to the better root cause. So this is a crucial part of the quality of your system. Next is a big transition, and this is the mentality of store the data, persist the data, which transforms something that until now was quite personal to you in the cloud, but it still implied that when somebody works with it, basically nobody else is able to see it. So what changes the thing is storage and persistence of the data. It gives you the ability to return to results. It gives you ability to share it. It turns your personal results into organizational results when your colleagues can come and pick up from something you did. You add the session storage. The most important in the session storage is to store inputs and results, because you need the question of what was asked from the agent and what it resulted in. And you need to go back and see the history of those results, or see them shared in context of your incidents. Most typical cases when the hyperlink to this is either sent to Slack chat so everyone can see the share, or attached into Jira issue, Jira ticket, where you pick up the session, maybe ask the follow-up question for that session, and your colleagues see what happened, and you see what happened from basically that independent agent that works on itself. There's also, for your debugging and improvement, you would need to store the transcript of, this is what is actually meant by session, is the transcript of exchange, what were the tool results, what were LLM responses, what did the human ask. In advanced cases, you store the traces and some KPIs like the metrics of cost and some other metrics, latency, how fast does it respond. It's a very crucial component of the life cycle for your agent because it's very hard to catch that ephemeral thing that works on your laptop and basically disappears very quickly, fades away into the history. A simple example. So in Commodore, we have our internal system where we can basically go and review all of the transcript from all of the sessions and see what exactly was LLM assistant requesting from the tools, which were the responses from the tools, and where were the gaps and how it all went. I should say that although this capability is important and crucial, you should not think of yourself spending much time there because when you automate things right, you will quickly run out of time. A human is unable to keep up with the pace of agent working on those sessions. You just need them in rare occasions when it has hallucinated. It will hallucinate for sure. And you have a question, why did you do that? Why? So this is where you will come and ask, why didn't you see it? Or maybe a tool call glitched and that was the explanation for it. Another example of what we do and what we practice inside Cloudia is that we have our own tracing. We tried to take the open source out of the box tracing solution for LLM agents. It did not work well for us, so we had to basically write our own very slim but serving us good. So we are able to see what exactly happened in which sequence inside the session of our agent, and we can spot some things that we do, like parallelization of things, how well our tool calls are working, how much time did the LLM spend in intermediate reasoning versus the final response, and how much time does it generally took for the whole thing to finish it. For example, this is a very real span of a root cause analysis session that analyzed something for some incident. Next step is everything that we have added on top of that system now really calls for a serious maintenance of that thing. First of all, you want to store all of the moving parts into Git repository. You would like to have a CI pipeline delivering that, so it more looks like cannot say liability, but it is really a thing to maintain, and it demands for some professional level monitoring also. For example, the KPIs that we send, the cost data, the alerts when the agents start to fail everything. Like recently, we in one of our testing environments, for example, we used some separate account which ran out of credits, and suddenly out of nowhere, all of the agents we were running were just not doing the thing, saying we need more budget. How do you spot that? How do you get notified about your agents degrading the quality? Some tools that they rely on silently start to fail, and the agent says, I'm fine, although the tool does not deliver it logs anymore, or something happens. For all of that, you would need to actually do the monitoring. So it becomes a service of its own. Maybe it's not your business to actually build and host and maintain the agents, but if you're going through the way of building your own AI SRE, you would have to unavoidably, if you take it seriously, to deal with that. And the more agents you run, the more the toil will be on you with regard of maintenance. And for example, in Commodore, we use Datadog extensively, and this is our internal Datadog dashboard saying that some tools are failing. what's the intensity of the request, what are the latency of those requests, and what are the typical exceptions that we are experiencing right now in our production for our customers. Another thing is like the cost aspect of it. How much does it cost us to run certain use cases for our customers? How much does it take per one session? How much does it take over time for in general? We need to really track the costs because it's easy for agents to burn tokens nonstop and basically get bankrupt anyone. So we are cost aware from the very beginning. And I would advise you to also build your AI SRE cost aware from the very beginning because surprises are unpleasant surprises. Next is the area that we realized early, probably not really. Yeah, but it's like for now it will be like we were like 6 months into developing our own AI SRE, and we felt that we are unable to predict uh, what will happen with the next change that we do. Will it get better or will it get worse? And when you are on the laptop, it's kind of easy. You change the skill, you change the setup, and then you just run the thing, and you can tell if it's good or bad, if it's used or not. But if you're imagining the automated way of for your agent to work when it really works in an unattended fashion with a lot of inputs, a lot of situations, you have no idea what happens there. And when we speak with our customers who start practicing their own agents, they say, when we ask them, how do you tell if it got better or worse? And in statistically measurable fashion, they say, well, we don't. So that's the situation on the market right now. Rarely somebody evaluates what they do and measure improvements. So for that, we know that the best thing to do is to actually leverage AI again. You just need to learn to do it right. Some naive things that I hear from the market and some of our customers or prospects is that we will ask people to provide the feedback. And indeed, we try to put into Cloudia the ways to gather the feedback of thumbs up, thumbs down, or something. Unfortunately, humans are lazy, and the optional things are optional for the reason and stand for the name. People skip them. Nobody has time to give the feedback and say something. So to not stay without the feedback, we actually explored and learned how we do our own AI SRE LLM as a judge. And I would say it's not as hard as one could imagine if you know how to tune the thing. And the simplest example I will give to you is that whenever you do this LLM as a judge, and for those who doesn't know, the principle of LLM as a judge is very simple. You take results of LLM working or agent working on a session, you take some parts of it, maybe just outputs, maybe outputs plus compilation of what it took as a process to get to there. And then you ask another agent, or rather LLM, usually it's a one-shot LLM call, you ask it to take some guidance, grading guidance, and give a score to that session. It's that simple. And sounds simple, but in practice it's quite difficult because if you would take a couple of hundred of AI sessions and you would evaluate with it, you would be surprised by the fact that LLM judge tends to be very bucketing. It would be giving on the scale from 1 to 100, it would be giving 70, it would be giving 30, 80, but never 73, never 38, and never 55, because it tends to choose to operate with like language concepts, not mathematical concepts. And over time, we learn that the best criteria for your grader instructions is that you can only find that out by experimenting and running them, but your criteria is that the output of distribution of the scores, the more Gaussian it is, the better your instructions are. The minute you see spikes there, you know that the instructions somehow hint LLM to basically use only 2 buckets or 3 buckets instead of giving more continuity. Look for more guidance, give it multi-modal scales, ask it to look at different aspects. For example, in case of AI SRE, you can ask it for how good did it give the evidence of the conclusion, how close did it get to the root cause? Did it stop at the symptom level, just stating the symptom, or did it actually get through several layers of the architecture to try at least to get to the problem? Another example, did it discover the change that led to an incident and made it part of the root cause analysis? So you can put all of those into your grading instruction, assign a weight for each, and then LLM will be giving you more uniform or Gaussian scores across your evaluated things. And this evaluation ability is actually a foundation for the other things like benchmarking, for example. The example I'm showing to you here is again a screenshot from internal system of Claudia of how we tell that the new version is better than the old one. In this example, the old version is much more good. It wins by 2.5%. The statistical saturation is not so good, but I will show you now the graph of how we measure statistical saturation. What is important to see in this example is that when you review the results, you also need to look at the duration, at the amount of tool calls, and at the costs. Because sometimes you can see one LLM, for example, we usually test every new model that comes out, we test them, we don't change anything, we change only LLM, and we compare, let's say, Claude Sonnet versus Opus. And then we can say, what is it better or worse? And we usually see that the newer model usually is better, but it's usually slower, it's usually more expensive, and we can then do educated decision. Do we switch the model? Is it worth it? Or 1% of quality of, in our terms, percent by the LLM as a judge, quality, is it worth 30% more of costs? So it's very, very big work to build the evaluation process so you can have this clarity. Another example is that we measure statistical saturation of the experiments, and we look at how fluctuations of the score become more saturated and plateauing, and we only conclude that the experiment is conclusive when we see that the statistical saturation happens. And for that, you can only look at the graph like this. And all of that is the foundation of next thing, which is, I would say, probably as big as building the AI SRE is building the benchmark sets and infrastructure for actually measuring anything with not only after the fact, but with predictive power. And it takes a lot of decision making of what would you include into your benchmarks. In general, LLM space is all about benchmarks. So this is how they brag about, and it comes from the machine learning times when there were these image recognition sets, and later there's LLM comparison sets of how LLM and agents resolve certain tasks. The difficulty for AI SRE is that you basically need to reproduce the production incident, and incidents are tricky. And if you want your benchmark set to actually measure AI agent in a tricky situation, you would need to reproduce the tricky situation. You cannot just snapshot whole world. That's too difficult. So you need to actually reproduce a Kubernetes incident. And for that, you would need to write the scripts, the validation that the breakage happened the way you wanted and it's not a different breakage. A lot of hidden work sits inside there. And you would need a combination of synthetic data sets and reproducible situations and scripts and infrastructure for that. And that volume of work is paid off by this freedom of answering the hypothesis within hours. If you would say, what happens if I change Claude Code for Codex? Or what happens if I add new data source to my system and I want the answer and I want that answer to be measurable and repeatably measurable. Or in our case, sometimes what happens, how do we compare to some other AI SRE tool? How do we gain the confidence and make sure that we are the best? We have a setup to measure that. Okay, I think I'm coming to the summarization of what we learned and some final notes. I don't think we need to repeat what we expressed. It's basically we started from AI SRE on your laptop, and then we gradually built around it the moving parts and qualities that would turn it from your personal success into company-wide success. And it's not so easy and trivial, but what's good is that it can be done gradually. There are things that are really hard to do on your own. And if we look slightly into the future, there are more building blocks that I didn't even mention. I could be building that diagram of AIs are even bigger and bigger. For example, we didn't talk about circuit breakers. We did not touch on LLM gateway that you want to involve sometimes. MCP gateway is another pattern that people like to use, and I like that pattern also because the MCP sprawl is real. It's too much of tool surface if you don't take MCP gateway as a pattern to use. Notifications gateway. How do you notify your colleagues, yourself, what happened? You need to handle that, how you integrate with the Slack. And Slack is such a complicated beast that it's not a pleasure to actually implement that. For many of these components, the open source is there. What you don't get with open source is you don't get the expertise. So people share the code, but you can only get the experience of what really matters in that code and what is not by only practicing it and really doing it. The reality is that building AI SRE is not the business of most of the companies in this world. And most of the companies would prefer to spend resources on their main business and not on the building of AI SRE. So you should be aware of what you're getting yourself into if you're really considering the success of the laptop AI SRE as a sign of let's continue, let's go. AI solves it for us. There are a lot of tricks waiting for you in that way, and we know that for sure because we built our AI SRE. But we are the platform. We historically do the SRE automation, so we build that AI SRE for our customers. We sell that, and this is how we learned all of the things that I shared with you today. And with that, I think this is the end of it. So if there are any questions, I would love to address those, and Nikki will help me to pick up the questions from the audience. So I'm not.
First off, thank you, Andre. We've got a couple that actually came in through the messaging here. So we have a couple more coming in. Okay. From Hasif, who validates, I like this one, who validates or judges the LLM judge?
It's not the first time I'm hearing this because it's really, and this is where I spend some time at some moment in my life really trying to philosophically answer this question. Is it solvable? the answer for now is there are two good answers. One good answer is that you have to put a human on really putting his opinion into those grading rules. And that's your judgment of a judge. So you basically, like real life judges, they are driven by the law or codex of the judgment. And this is what is their guideline for judging. So this is the role of a human to create that guideline. This is how you steer it. You don't need to be judging or evaluating your judge. That's one thing. Another thing is that as everything happens in this world, we try to offload that to LLM. And if your LLM as a judge runs on a simpler model, then you can take stronger model and ask it to basically review. This reminds like real life when there is the court in the city, and then the global court of the whole country can supervise and review and override the decisions. So if you have stronger judge, you can use and refer to that to actually evaluate if the judgments are good. But then we have the second level problem of who judges that judge. The human, the human, the human. This is where we still take our spot. When the moment that LLMs will take over those like ultimate decision making, we are doomed because we are obsolete then.
Well, I hope we don't become obsolete. We've got one more question, and hopefully we'll be a little bit more of a happier note. Is a question here from John. And after going through building your AI SRE, what would you not build again?
What I would not do again. I only built one AI SRE in my life, and that's Claudia. The one thing that I would do is I actually, knowing what I know today, I would not change from my own agent harness into the library that we use, which is Agno. I would take and keep developing my own agent harness because we know enough of non-standard things. We do enough of non-standard things that like the parallel requests, intermediate injection of additional context. So when we try to migrate from custom solution into generic library, we had to either give up some of those tricks we did or to really step out of our way and hack basically the library to still deliver those things. So I would say that our development velocity was somehow affected by the fact that we were not brave enough to really invest into our own harness. But again, like we are solely doing that, we are solely building the AI SRE, so we have time to actually deal with this and write our own harness. The idea of saving time by using library did not really work out for us. It's in my opinion, maybe my colleagues have different opinions.
All right. Well, thank you, everybody. Definitely keep sending those questions. We'll be able to message you.
Wait a second. Wait, I see one more question. The question is, which language is the SRE platform written in? SRE platform is big thing. Most of the things around the agent, because the agent harness itself is in Python, so Claudia, most of its parts is written in Python. And especially today with coding agents, this is the language that they would choose by default. But in general, the platform that is surrounded with it, it also involves Golang, because Golang is what we use in our authentication, RBAC, all of those privileged things that I was showing to you in one of the beginning slides. It's like here in this RBAC. Oh, like let me show that to you in this RBAC. RBAC, where did it appear? It's right here. So in this situation, there's a lot of Golang involved in this user identity propagation, and then in this tool calling and MCP. There's also some of the Golang involved. It's a big thing. It's a lot of moving parts, and also HTTP APIs. We build that for efficiency reasons. Python is not so great for efficiency and scalability in some places, so we build it with Golang.
Amazing. Well, thank you so much to Andre and to everyone who was here. We'll be sending you out a follow-up with everything. And this you'll be able to watch this again to your heart's content. But if you have any more questions, definitely send them to us. We love these types of things. We love sharing and wishing everyone a great day wherever you are around the world. And we look forward to seeing you again soon. Have a great day and stay cool out there. It's hot. Have a good one.
Thank you. Bye.